Hello class, this week we are going to be talking about installing and configure the Dynamic Host Configuration Protocol, or DHCP for short. DHCP provides automatic IP addressing for Windows clients. An industry standard protocol use DHCP to ease the burden of maintaining IP addresses on small, medium, and large networks. DHCP allows you to create pools of IP addresses, called scopes, from which clients can request a temporary IP address or a lease. By changing messages when a client powers on or connects to a network, DHCP automatically configures the client's IP addresses information on the basis of the administrator-defined configuration on the DHCP server. DHCP is a layer 4 protocol that uses the User Datagram Protocol, or UDP for short. DHCP clients use UDP port 68 to send and receive DHCP broadcast communication, and use the UDP port 67 to send and receive DHCP broadcast communication. Through this communication, a DHCP client and a DHCP server can provide each other with information necessary for allocating an IP address and configuration information to the client. DHCP offers four main benefits for managing the transmission control protocol in a protocol network. First, flexible configuration. That means that DHCP allows you to implement IP address and change easily. Second, a scalable design, which means that small and large networks can benefit from DHCP. Whether you have 10 clients or 1,000 clients, DHCP manage IP addressing. Third, centralized administration. DHCP allows you to store IP addresses and configuration information in a single central location. Then the server stores all of the IP address, lease, or reserve in its database. You can use then the DHCP console to review this information. And finally, automatic host configuration. DHCP automates the distribution of IP addresses information to DHCP clients on a network. This allows computers to be deployed without manually IP configuration. To understand DHCP, you need a good understanding of the components necessary for implementing DHCP, which includes lease, scopes, reservations, option, and relay agents. We are going to start talking with DHCP about DHCP leases, A DHCP lease defines the amount of time or duration that an IP address is loaned to a DHCP client. DHCP clients and DHCP servers use leases to manage DHCP. A client uses a lease to determine when lease renewals are attempted and when it must relinquish its temporary IP address. For a server, a lease acts as a placeholder in the DHCP database. When a lease is issued, the IP address is removed from the available pool of IP addresses. This prevents the same IP address from being issued to multiple clients. A DHCP lease displays information including the DHCP client name, the IP address, the MAC address of the client, and the lease expiration time and date. A lease duration is the amount of time a client keeps an IP address before releasing it. Default lease duration for Windows Server 2008 R2 are 8 days for wired clients and 6 hours for wireless clients. Determining the duration for a lease requires considering the following factors. First, the client type. Second, the connection time. And third, the number of IP addresses. The second component that we must understand in a DHCP network is the scope. And a scope determines which IP address are allocated to clients. A scope defines a set of IP addresses and associate configuration information that can be supplied to a DHCP client. Also, a scope must be defined and activated before DHCP clients can use the DHCP server for dynamic TCP/IP configuration. You can configure as many scopes on a DHCP server as needed for your network environment. A DHCP administrator can create one or more scopes on one or more Windows Server 2008 running the DHCP server service. However, because DHCP servers do not communicate scope information with each other, you must be careful to define a scope so that they don't multiply in the DHCP server. The IP addresses defined in a DHCP scope must be contiguous and are associated with a subnet mask. If the addresses you want to assign are not contiguous, you must create a scope encompassing all the addresses that you want to assign and then exclude specific addresses or address range from the scope. We're actually gonna be doing a lot for that for you guys to understand better this concept. You also can create only one scope per subnet. Remember, only one scope per subnet on a single DHCP server. To allow for the possibility that some IP addresses in the scope might have been already assigned and are in use, the DHCP administrator can specify an exclusion range. That is one or more IP addresses in the scope that are not handed out to the DHCP client. An exclusion range is a limited sequence of IP addresses within the scope range that are not to be excluded from the DHCP service offerings. When exclusion ranges are used, they ensure that any addresses within the defined exclusion range are not offered to clients of the DHCP server. You always should exclude all of the statically configured IP addresses within a particular IP address range, like the servers, print servers, and so on. Once a DHCP scope is defined and exclusion ranges are applied, the remaining addresses form what is called available address pool within the scope. The pool addresses then can be dynamically assigned to the DHCP clients on the network. Besides an IP address, DHCP address assignments contain basic settings or DHCP options that our clients need for proper network communication. For basic networking needs, the following options that I'm going to mention are usually specified to a DHCP client via the address assignment: IP address, subnet mask, default gateway, primary and secondary DNS servers, primary and secondary WIMS servers if you need them, and finally the DHCP list expiration. You can define the options when you are creating the scope, or you can modify the options later. There are two options types that you will use more often. First, the server options, that are settings defined per server that apply to all of the scope on that specific server. Or second, the scope options, that are settings that are defined per scope that apply only to that scope to which they are added. Whether to create a server option or a scope option depends on how each client uses the settings. The server options are often used for options such as DNS, WIMS, or other network resources whose IP addresses are the same for all of the scopes. You use scope options for router options because each scope represents a subnet or part of a subnet, and each scope often has a unique router IP address. Scope options override always the server option. So in any conflicts between option settings such as DNS servers, the scope options values take precedence. DHCP reservation enables permanent address list assignment by the DHCP server. Where reservations are used, they ensure that a specific hardware device on the network can always use the same IP address. Reservations must be created within a scope and must not be excluded from the scope. Excluded addresses are not available for assignment to clients even if it's reserved for a client. An IP address is set aside or reserved from a specific network device that has a MAC address. This MAC address is then associated with a specific IP address that is the one that it goes to the reservation scope. Therefore, when creating a reservation, you must know the MAC address for each device for which you are reserving an address. The MAC address can be obtained by keying the ipconfig/o at the command line.